Hello and good evening. My name's Matt Gaff and I'm here to talk today about the new safety challenges that are faced with autonomous vehicle technology. Just some background around why I'm doing this research project. There's approximately 1.35 million people lose their lives on roads globally each year, and 9 in 10 of those fatal road accidents are usually caused by human error. This autonomous vehicle technology will really bring some positive and negative disruption over the next 20 years due to this emerging technology. Significant positive and benefits out of this is that there should be an improvement to road safety. There should be reduced accidents and there should be reduced road fatalities. Also, more people will have access to vehicle for transport. So, for example, those people who are unable to drive a vehicle may be able to use autonomous vehicle to get from point A to point B. That said, there is some negative impact around this change, and those with a driving background and jobs in driving may see jobs reduced in that area as the autonomous vehicle comes into play and into the market. So the main approach of this particular research project, I posed two questions. The main question was, what new safety and privacy challenges will the adoption of autonomous vehicles introduce? I also had a sub-question of what impact will new safety and privacy challenges have on road fatality statistics? For the research methodology, this was a literature review of multiple articles, and an annotated bibliography was produced. Also, a final report and this recorded presentation is also being produced. There's also a project blog which captures weekly updates and all the artifacts that have come out of this research project. So let's dig into the results and the findings of the areas of focus that I looked at. The three main areas were issues that may impact autonomous vehicle adoption, and this is around trust and acceptance of the technology. It's around law and legislation, and also the road infrastructure that's required. We're going to look at autonomous vehicle disengagements, and we're going to also look at privacy and cybersecurity. So some of the issues that may impact autonomous vehicle adoption is around, what's going to happen with this. There's lots of questions. So Adnan et al. Was published a document in a transport research journal, and then posed some really good questions about potential users of autonomous vehicles. For example, what happens if the technology fails? Will it cause an accident? Will it just stop? Could it cause a fatality if it really failed catastrophically? If a crash is imminent and unavoidable, who does the vehicle protect? Does it protect the occupants? Does it protect the other vehicle or other road users? Does it protect pedestrians? And the big ethical question is, what makes that decision? Is it something that's legislated by law? Is it a standard that the automotive industry makes and applies? Or is it something that the vehicle owner can adjust? The other big question is, if an accident occurs with the autonomous driving activated, who and what is liable? So in relation to law, regulation and liability, and looking at this from a lens within Australia, the National Transport Commission is responsible for driving the law reform around autonomous vehicle adoption and bring them onto our roads in Australia. They've called out that there's 700 regulation and legislation components that do require updating. A part of this reform is there's a key focus on safety. So it's not just about the introduction of this brand new technology that's not available as of yet, but also once it does come into play, what happens 10 years down the track when these vehicles are 10 years, 15 years old, making sure that there's law and reform around how that's managed. They'll also look at who and what is liable when an incident or an accident does occur. And there'll also be the updating of accident insurance schemes to make sure that those that are injured in autonomous vehicle accidents are covered and looked after. There's a similar theme around countries globally and a call for action that, the governments need to come on board and really push forward with this regulation. Once this is in place, this will help build trust and positively impact the adoption of the autonomous vehicle technology when it actually becomes available. The other thing that I touched on before was in regards to remote and rural road infrastructure. So Perez et al., who these researchers are from the Monash University in Melbourne, did a study and described some of the potential challenges for using autonomous vehicles in rural and remote areas. One thing they did call out is that 65% of road fatalities occur in rural and remote Australia. This is a really large overrepresentation, figuring that only 1/3 of the population of Australia lives in these types of areas. So autonomous vehicle control requires good quality roads and line markings to operate. And what we do know once we get out rural and remote is that we don't have that. We might have dirt roads, or we might have poor quality bitumen roads and roads that don't have line markings. And indicators at this stage is this is the key of the road infrastructure for autonomous vehicles to be able to steer and function. This research group calls for high quality road information data to become available in Australia. At the moment, it's not. And what better data will do will help improve and target appropriate infrastructure investment, resulting in better and safer roads in our rural and remote areas. And good quality and safe roads will help realise greater safety benefits from the autonomous vehicle technology and hopefully ultimately reduce that road toll. So we're now going to look at autonomous vehicle disengagements. So an autonomous vehicle disengagement is when the driver needs to take over control of the vehicle. So Chen et al., which was a document published in an IEEE journal, talks about defining what a driver takeover is. And this is where the driver needs to take control of the vehicle. And this can be with very, very short notice. They outline two types of disengagements. So there's passive disengagement, where the technology identifies a failure and it initiates the driver to take over. And that's usually via audible beep and alarm, and needs the driver to take control very quickly. The other type of disengagement is active disengagement. And this is where the technology thinks everything's fine, but the driver doesn't and takes over. So it might mean the vehicle's not braking fast enough to avoid a collision, and the test driver or the driver in the vehicle may need to apply the brakes, and that will signify an active disengagement. The average takeover time in testing ranges from 0.86 seconds to 3.06 seconds. Now, one thing to call out here is that this is for trained testers of autonomous vehicles. When we talk about the general public, this may be a lot longer for them to take over, and that could have really bad ramifications. The other thing that the study calls out is that software failure and software limitations account for 80% of the disengagements. So what can be done to improve this around disengagements? It's just so important that there's less of these. So Strickland and McNellis call for agreement in terminology and improved data to be made available to the public. So at the moment, there's only data being submitted to the California Department of Motor Vehicles, and it's very limited, and there's no agreement in terminology of what specific things mean. They're also calling on encouraging organisations that are testing these vehicles to make sure they are using virtual test platforms and make the results public. For example, Waymo drives over 20 million miles per day in their virtual testing platform, and they call out that that provides much better insight than on-road driving. What we did find is that multiple parties recommend real-time driver attention and engagement monitoring. So this is to make sure the driver has the ability to take over from driving when it's required. The US National Transport Safety Board recommends this real-time driver attention monitoring and says it will help with adjusting away from automation complacency, which is where people get too trusted in the technology, especially at this early infancy stage where it does fail quite often. Monitoring also may have prevented a fatality on an Arizona pedestrian in 2018 being hit by the autonomous vehicle that was under testing. So really sad situation there for the first recorded fatality in the US in relation to a pedestrian. So now we're going to touch on privacy and cybersecurity. So there's lots of concern around privacy. So what data is this vehicle going to capture? What location, what vision from the cameras, how a person drives, how fast they drive, how long is that data retained? Where is that stored? Is it stored in the cloud or is it only accessible via the vehicle? And who has access to data and what can it be used for? These are the burning questions, and this has a lot of concern from a lot of people. Collingwood, who published an article in the Information and Communications Technology Law Journal, justifies the need for standards and regulations around this. She claims that the smaller amounts of data could be better and only accessed for agreed events or scenarios such as a car accident. Having the regulation and standards around the data management really provides some certainty to users in relation to provide privacy and removing that potential barrier when using the automated autonomous vehicles when they do become available. From a cyber security perspective, there's lots of things that could happen. So with improved connectivity, there's more enticement for mobile malicious actors, and there is general concern for cybersecurity safety of autonomous vehicles. Chattopadhyay et al. In an IEEE publication describes how autonomous vehicles are susceptible to a cybersecurity attack. A compromised vehicle could be simply forced to stop or fail or rendering it useless. In worst case scenarios, it could be instructed to crash and even cause death. So security is really a large concern for potential users. And when I talk to people around the office, this was the number one thing that came up. So ways of how we could reduce this risk is via using a security by design framework, which will help improve the cybersecurity of the autonomous vehicles. And this is claimed by Chattopadhyay et al. In the IEEE publication. The framework functions by performing security design and planning, and then incorporating trust management, security technology, and security testing all into that framework. So whilst it's not going to remove the risk altogether, it will be reduced and provide potentially for a safer autonomous vehicle. The other part to think about is the cybersecurity and people. So Linkov et al. In a psychology journal have performed human factor research into the people aspects of autonomous vehicles and cybersecurity. It is likely a human would unknowingly assist in allowing a cybersecurity attack, potentially by a phishing attempt or authorizing an update, which is not from a legitimate source. There are groups of people that may be more vulnerable than others to an attack. And also they need to study around how will people react to an attack if it took place on the vehicle they are in and what they would do. Linkov et al. Calls for more human factor research to take place. And it's really important that this is done because, if something is compromised, we really want to know how that could be handled, and that will put confidence in the user. So to conclude, new safety and privacy challenges will be faced with autonomous vehicle technology. These challenges may impact the adoption of autonomous vehicles if not mitigated. Some of these options on how to address that has been explained in this study, in this presentation, and also in the final report. There is a lack of evidence and research in relation to how these new safety and privacy challenges will actually impact the road collision and fatality statistics. There is a recommendation for further and ongoing research that will be required due to the large disruptive change and the consequences should the technology fail or be compromised. Thanks again for your time and have a great day.